Hello and welcome back to the GCSE Maths Hub. Today we're going to be talking about fractions. Firstly, we're going to be talking about how to simplify fractions. So to simplify fractions, you divide the top and the bottom by the same number until it's impossible to do so. So let's start off with the example of 18 over 24 and let's simplify it. So 18 over 24, we can divide both by 3 to make 6 over 8. And now we can divide both by 2 to make 3 over 4, and since there's nothing that can be divided by 3 and 4, you stop here, and the simplification of 18 over 24 is 3 over 4. So now let's talk about mixed numbers and improper numbers. So a mixed number is an integer and a fraction, whereas a improper number are top-heavy fractions. Below we can see that mixed numbers are written as an integer and a fraction, whereas improper are top-heavy, meaning that the numerator is larger than the denominator. So now let's move on to the example, where we have to write this mixed number as an improper fraction. So let's think of the mixed number as adding them, and turn the integer part of the mixed number into a fraction. So it would be 4 plus 2 over 3. And to turn the 4 into a fraction, we would do 12 over 3 plus 2 over 3. And it's 12 over 3 because 3 over 3 is 1, and then 4 of them together would make 4. So 1 plus 1 plus 1 plus 1. So 3 over 3 plus 3 over 3 plus 3 over 3 plus 3 over 3 would equal 12 over 3, which is the same as 4. So you plus them together, so that would equal 14 over 3, and I do explain how to add fractions later on in this video. So now let's look at multiplying and dividing fractions, starting off with multiplication. So from this example, we can see that we have 2 over 3 times 1 over 3. So for timesing, it's really straightforward. You do the top times together over the bottom times together. So 2 times 1 is 2. Over 3 times 3 is 9, so this equals 2 over 9. Dividing is a little bit trickier, so we have 4 over 3 divided by 2 over 5, and all you have to do is flip the last fraction, so 4 over 3 to make it times, so 5 over 2. So I've just flipped this one around to make 5 over 2 instead of 2 over 5, and now we just times them, so 20 over 6, which is just timesing the 5 and the 4 to make 20, and the 2 and the 3 to make 6. So now let's look at how to find the common denominator. So the common denominator are fractions with the same denominator, and the denominator is the bottom number, it's just another word for it. So as we can see in this line of fractions, we can see that this fraction, and this fraction all have the same denominator, so you would say that these three have a common denominator. So now let's look at a slightly trickier example where we have to put these fractions into ascending order. So firstly, let's find a common denominator between these three numbers, and I'm going to pick 60 because 3, 4 and 5 are all the denominators, and they are all multiples of 60. So 8 over 3 can be written as something over 60. 3 times 20 equals 60, so 8 times 20 equals 160. Now let's do the same with 5 over 4 equals something over 60. 15 times 4 equals 60, so 5 times 15 equals 75. Now for the last one, we can do 12 over 5 equals something over 60, and 12 times 5 equals 60. So 12 times 12 equals 144. So now we can write these fractions. Now we can have these fractions, which are the same as these fractions, just written differently. They mean the exact same number, and now we can write them in ascending order because we can look at them and pick, this is the smallest, second smallest, and biggest. So now let's look at adding and subtracting fractions. So you basically got to find a common denominator between the fractions and then add or subtract them. So let's do this example. So 6 over 7 minus 30 over 10. Let's find a common denominator. I'm going to pick 70 because 7 and 10 are both multiples of 70. So 6 over 7 equals something over 70. That would be 60 over 70 because I'm timesing the bottom by 10, so I'm timesing the top by 10. And now let's make 30 over 10 equal something over 70. So I'm timesing the bottom by 7, so I'm timesing the top by 7, which is 210. So now we have these two numbers. We're going to do 60 over 70 minus 210 over 70. So now it's going to be something over 70, and we just focus on the top numbers. So 60 minus 210 is minus 150. Now let's do the exact same thing, but change the symbol with the add up here. So we have those two numbers, so it would be 60 over 70, add 210 over 70 equals 270 over 70. So I hope that makes sense. You basically got to find a common denominator between the numbers, and then you can add them simply without changing the bottom denominator at all. You just add the numerator, which is the top number. Here are a few odd examples that you just need to know for fractions. So let's start with the first one. What is 9 over 20 of £360? So with these kind of questions, you need to know that you need to times the numerator and divide by the denominator. It doesn't matter which order you do this in though. So the easiest for this equation, I think, would be to divide by the denominator first. So let's do that. So 360 divided by 20, and we do that first, and then we times by 9, which equals 18 times 9, which equals 162. And let's try this other example, which is write 180 as a fraction of 80. So this is really simple. You just do 180 over 80, and then you cancel down, which I've shown you previously, which would just make 9 over 4. So now we're going to look at changing fractions to decimals to percentages and back and forth. Okay, so looking at this table below, we're going to start off with the first line, which we only have a fraction for, and we're going to have to find the decimals and the percentages. So let's start off with finding the decimal of a half. This is pretty straightforward, it's 0.5, but there's a way of doing this when it isn't straightforward. So as you can see down here, we have divide. From fraction to decimals you divide, and that means you go 1 divided by 2. So the top one divided by the bottom one equals 0.5. And you put 0.5 in the decimals, and then going from decimals to percentage, you're going to times by 100, so that equals 50%. So a half of an apple is 50% of an apple is 0.5 of an apple. So you have half the apple. Now let's look at going from decimals to fractions and from decimals to percentages. So we're going to look at going from 0.25 as a decimal into a fraction, and I haven't written anything into this loop here because it's very tricky. So this is just something you need to learn. So there are 2 points beyond the decimal point. That means you're going to have 100 at the bottom. So however many zeros there are is however many points there are beyond the decimal point. So if it was 0.251, it would be 1,000 at the bottom because there is 3 points beyond that decimal point. And then all you have to do is put all the numbers beyond that decimal point on top as well. So it would be 25 over 100, which equals 1 over 4. And then this we know as a percentage as 25% because we just times that decimal by 100. Now let's look at 2 over 10. We know that 2 over 10 as a decimal would be 2 divided by 10, which would be 0.2. And now we times that by 100 to make 20%. Now the last one, we have more than 100%, so that would be 2.5 dividing by 100, get from that percentage to the decimal, and now we do the same thing we've just done, which would be 25 over 10, which can be simplified to 5 over 2. It's 25 over 10 because there's only 1 point beyond that decimal point, so it's 10 at the bottom, and then you put all the numbers on the top, so 25 over 10. So the last important topic with fractions is recurring decimals, and there's two different points of this, which is write recurring decimals as fractions, and then the flip of that, which is write fractions as recurring decimals. So let's start off with the first example. So what you want to do is do your recurring decimal as equal to r, and then you want to multiply r by the power of 10 to move it past the decimal point by one full repeated loop. So here this would be 1,000, because as you can see here, 1,000 r equals 234.234, and then this part is recurring, which moves the whole loop to the left hand side here. So now you want to minus that bottom line by that top line, which would give you 999r equals 234, and then you can simply write your recurring decimal as a fraction by moving that 999 on the other side. So now let's move on to the second example, which is slightly different because the recurring part is not right next to the decimal point, so it goes 1 and then 6 is recurring. So the way you would do this would make 10r equal 1.60, moving that recurring part to the right next to the decimal point, which makes this part easier. So what you want to do next is do the next power of 10 up, which would bring that 6 across. And then you want to minus the 100r minus the 10r, which would make 90r equals 15, because there is that 1 there, so 16 minus 1 would be 15, and so that would make r equal 15 over 90. So lastly, we're going to write fractions as a recurring decimal, which is a slightly more difficult topic, but the only thing you need to remember here is to try and make that denominator number equivalent to all nines. So whatever it is, you've got to see all nines on the bottom. So I'll show you what it is here. So you times by 3, which would be on the top as well, to make the fraction the same, which would leave you with 24. So these equal the same because I'm timesing the top and the bottom by the same number, and I do get that 2 nines on the bottom, which is what I'm looking for, which makes it so easy to write it as a recurring decimal, because you just pick those 2 numbers up, and whatever's on top, you find that loop. If it's one number, you just put the dot on the top. If it's more than one number, then you put those 2 dots to make that loop. I hope that all makes sense, and thank you for watching.